And welcome back to me, a very dairy enthused engineer, and welcome back to the channel. Today we'll be covering a game called Trailmakers. You know, you and me one-on-one. What am I covering? Walker designs. That's what you've been calling for. That's what the people have been wanting. What the heck? Okay, let's go. So, what I've been asked to do, a little video by one person, that's right, I'll make a video just for one person, is a quick tutorial on how I make walkers. Because I've got a sort of method for working out the logic system of the walkers. Of walking, and there's two different styles for doing that. So I'll go into it. One style is a sort of two-state walker, where basically you're switching between one extreme and another. And then there's a few little tuning things you can do in that, with like how quick you're moving between the two states, the delays and stuff. And if you have multiple parts to a leg, you can delay like one between the other. I've never talked like this before. I'm like a receptionist right now. I love it. So first, two-state walkers. So what am I going to do first? I am going to show you the type of leg we're going to build. So I just want to show a simple leg design. So it's just a rotating hinge. So that's going to rotate the leg around a center point. That gives us our forwards and backwards movement. And now the other part of a leg is basically lifting and placing the foot. So there's a couple ways to do that, but the way I like to do it, because I have a great big interest in insects and their mannerisms, because I think they're funny and cute, is now what you want to do is you want to lift and move the leg between each step. So you want to lift it so it has no friction on the floor, and then move the leg, reset it to the other state, and then move it again. And so that's why you have your rotating hinge here, and then what this servo is going to do is just lift this up and down. And so that'll mean that whenever this moves forwards, this drops down and it moves backwards. So that is the basic leg design I'll be covering today. And this can work for various ones. So this is that same leg design, just expanded out into 4 of them. And what we'll do is we'll quickly just add some suspension on the ends of these, just so that we can get a little bit more height off the ground, because I don't know if I'll have any parts dragging. I don't want this to drag on the ground. Yes, and then what we'll do is we'll start the coding. So this is the part that I like. This is the part that I do. That I like doing. Where is my logic? There it is. So I have a bunch of OR gates. So I can look at my leg, and this is a two-state walker. So I need 2 gates. So the length of the walking animation is going to be 2 logic gates. So that's the maximum it's going to be. Then it's the amount, and then the only other thing that increases the amount of logic gates that you need is whether you're going to have the separate joints fire at different times, like whether they're delayed. That's the only other thing that happens, that causes it to sort of change. There's a couple of different ways to do it, but I'll show how I like to do it. So we're going to start off with these hinges that rotate left and right, or rotate the legs so that I can get forwards movement. So I've selected them. I'm going to set them to 45 degrees, just leave them 45 degrees, and a speed of 0.5. I'm just choosing that randomly out of thin air. And then these ones I will set to, maybe I only want them to lift for 15 degrees, and we'll also set their speed to 0.5. So the speeds between the 2 different legs can be different. You need to account for how long that takes. Okay. So how I do it is I don't touch I've set that part of the legs up. Now what I do is I set the logic cycling like input loop sort of a thing. So I want it to activate on W. I want both of them to activate on W. I've all gates in this logic loop are going to be activated off a key. I don't like having one gate that activates them all. And just input that, because it's just much rather this way. You have to worry about it less. So we'll have it fire for a duration of 1 second, and then pause for a duration of 1 second. And then we'll have an output of 1, so that's going to move us to the first state. And then the second gate, we're going to have a delay of 1, so it's going to wait for this one to fire. Then it's going to fire for 1 and pause for 1. So it'll fire 1 second after this one does, and that means they're going to cycle between the 2. And we'll have an output of -1. And so if we start it, and then we just look closely at them, I can't zoom in any further. I'm just holding W. You can see they switch between the 2, and on the right it goes from positive output, negative output. Positive output, negative output. Perfect. So we will then take these 2 and we will attach them to these inside servos And so we're going to be looking to see what they do, because we want them to sort of move in the correct direction. So for a 4-legged walker like this, you want the servos, like the left side servos, you want them to move closer, that you want them to basically be rotate opposite. So according to the side they're on and across. So diagonally, they're going to do the same thing, but vertically and horizontally, they're going to be opposite. So you'll see. So I'll press W. You see it. I'm just tapping it so that I don't have to go and see the whole cycle like that. We can see that the left side is doing the same thing. So they're doing the same thing vertically, but not horizontally. So we'll just switch the output of these. And when I have to switch the rotation, I don't touch the logic gates. I only touch the servos. Because then I can customize how I want them to rotate. And that means that they do what I want, and then later if I plug another logic gate in and I tell it to move forwards, all of these 4 are going to automatically move to the correct direction. I don't have to worry whether my logic gate is a proper negative or not, or I don't need to put extra logic gates in to account for the 2 rear servos. So now if you press W, see it's doing the correct thing. There we go. So we like that. Perfect. All right. Okay, now for the second part of the circuit. What I can do is you can also plug these into these legs as well, and then they'll all fire at the same time. And then you only have 2 logic gates for the entire system. That's a very easy way to do it. And then you just do the same thing. You just customize. Actually, I'll show you how to do it. I'll show you what that does. So I'm just going to press tap W to see which ones are lifting up and which ones are dropping down. So we see the legs that move backwards need to drop down, and the legs that move forwards need to lift up. So this front servo here needs to be negative, and this front servo here also needs to be negative. There we go. Okay, there you are. So what we'll do is we'll just lower the angle of these so that we can get a nicer walking animation. And then we'll also lower the strength to 50. Lowering the strength is paramount if you're a very simple system like this. It just adds that little bit of give, which makes it so much smoother. So we'll see if we can walk now. Lol. Yes, but there we go. So you can see that the opposing legs are lowering, the other ones are raising up. So the way to make this a little bit better is you take... it can't balance necessarily on just the 2 diagonal legs. So if we extend it forwards like this, don't forget to rotate if you copy over, and just place these legs a little bit further forwards, just like so. Then we'll see that they'll raise up like that, and we can have a nice walking animation. So let's try and walk uphill, and we'll see how fast we can go. Interesting. There you go. But that's the very basics of making a walking animation. All right, so the second method. I'm just going to delete these front ones so I don't have to deal with them at the moment. The second method is... Oh, no, not the second method, sorry. The other way to do the 2-state is you delay joints. And so that means you can get just a little bit of a smoother animation. So basically, we've split up what these logic gates were doing into 4 sets. But what we're going to differentiate is basically, we'll say offset these by an extra 0.25 seconds. So that means the legs are going to raise and lower 0.25 seconds after... Actually, that's wrong. We want them to... there we go. We basically want these to raise and lower before we walk. That means that we surely are on the ground. So we'll give it 0.25 seconds to do its job. So basically, okay, what's happening now is if I put them in order, is we have the legs raising and lowering, and then so they'll lower, or a set will lower, then we'll walk forwards, and then a set will raise, and then we'll take the next step. And then that just means that we're not doing everything at once. So that can improve how smooth the machine operates. Let's just put this down, move it forwards. And we might just want to move it forwards just to get out of the way of that one. All right. So hopefully it's easy to see. So yeah, there we go. See? So now it takes its step in between. And that just makes it a smoother animation overall, even though it's pretty simple. We have literally no grip on the ground at the moment, so that's why we're sort of sliding. So you just put friction pads on or something.